Hi everyone and welcome back to the desk. Today I have a quite large item on it, and it's this AM radio and clock light that belonged to my parents, and it's ages long and it no longer works. And given that it's starting to be summer season and we're gonna start our camping trips, I thought I would give it a look and figure out if I can make it modern and maybe make it useful for us on our camping trips. In terms of feature, it has a big light in the front. Then on the top, it has a pointy, so a directional light, and a blinker in terms if you are in hazard, so you need to mark a vehicle or something. It used to be charged on the mains, and I believe because of the weight it has a lead acid battery that no longer works. So it's 6-in-1 radio, LCD clock, searchlight, fluorescent light, blinker, and alarm. The idea is that we'll try to figure it out, maybe replace this with LEDs, replace the front lights with LEDs, add a lithium battery inside, and generally make it a bit more useful. On top of other problems, the original antenna in here is broken off, so I have a replacement that we could hopefully insert inside and have it in the device. We'll see. So that's one of the fixes that we also need to do. And before going any further, I want to thank today's sponsor, which is PCBWay. So far, they were able to produce PCBs in many colors, but now they are introducing their revolutionary full-color PCB printing technology. With the new UV printing equipment, you can now achieve high-quality, vibrant images on a variety of materials, including fiberglass, metal, ceramics, and flexible boards. Whether you need precise detail for intricate designs, or you want to add a creative touch, PCBWay UV printing ensures firm, clear, and fade-resistant results. Plus, it's safe for the environment and provides a healthier working atmosphere. Elevate your PCB projects with PCBWay. Visit the link below to get started today. Now, to start opening it up, there is a switch here in the front that allows you to take out the front cover, and that allows you to rotate and take out the fluorescent lights. So I don't think I will be using them. Okay, this one is even broken. Okay, let's try and remove this. Okay, and there are some screws on the bottom and here on the top that I'll remove. And here is the light somewhat apart. I need to desolder a few of the wires. So there are two from this battery holder that are for the clock battery in the front that I will remove. So we will release this whole back cover. And also we have two wires here on the front going out of the battery. And this is a 6-volt battery. So we'll see how we're gonna deal with that. Probably we're gonna go with 2S, but before doing any work, I want to remove the battery and make sure that the whole thing works and that we do have a usable part to work with. Otherwise, it will be just a mess because I really want to reuse the radio that's inside. I want to reuse the controls and the lights and everything. So let's see how that goes. And here are the two parts separated. This is the battery that I desoldered from there together with the transformer that's used for charging. We'll see if we're gonna use that or not, but first let's verify that this works. So I'm gonna provide 6 volts from my bench power supply on this, and we'll see how it reacts. So the radio seems to be working. Now this had an alarm mode. Let's see if that works. No, that doesn't seem to work. Although it's using about 400 milliamp. Maybe that's the drivers for the fluorescent light, because that also triggers. Now this one doesn't do anything, but then on the lights, this is 200 milliamps, this is 400 milliamps. Maybe I need to put on the alarm here. I'm gonna lower the volume in video if that works. And it does. Okay, and on this side it triggers the light. It says emergency for some reason. And let's see if anything works up in the front. So you could see that lights up and the blinker does not. So there it is. So probably we have a loose wire somewhere. Yeah, but I don't think that we're gonna use, or maybe we'll see. That's an interesting thing. Now for the flashlight part up front, I've taken apart this before and I've seen the style of the lights that it has inside. So I ordered few that are LEDs and I'm gonna replace them with that. So I'll start with that and we'll see how it goes. This unscrews from the top and it gives us access to the light bulb. I think that this is removed like so. So we take out the bulb from the back, install the LED version, and we can secure it. Let's see if that works. Okay, and that's really nice and bright. And there is also this other one that's in the flasher, so we need to take out this piece here. Okay, so this is the old one. Let's add the LED version. Okay, I'm gonna crimp those a bit because I don't think that makes a good connection. Okay, let's see if that works. And it does, along with the blinker circuit. And that actually provides a really nice spotlight. I really like that. Up here in this head section, I remember that at one point this was able to rotate, and so you could have it pointing to the side, but apparently that got broken off and this is now glued. I don't know when that happened, but this is glued with super glue. I'm gonna leave it as is for now because this is also usable like this. So we have a nice light that we can use, so I'm okay if it doesn't rotate. I'm gonna now switch focus and try to figure out how we can run the LEDs out of here, and let's see what voltage is there. And for that I'm gonna open up this circuit here and we'll see how the fluorescent lights are powered. Okay, so I've been playing with the circuit a bit to figure out how it works and how we can rewire it to power the LEDs from the built-in switch, and this is what I came up with. This is connected to ground, and this is the switch. I first removed it, but now I return it to make sure that the connections are right. And as you can see, none of the outputs are actually grounded. And now let's turn on the switch. So we turn on the first light, and now ground is connected from here through this, and it's connected to this wire here as well as to this wire here. And what that does, so let's verify that. So this is ground going to the first input of the circuit, and this is again ground going through a resistor to both ends of the fluorescent lights. And having ground connected here, if we power this on, we're gonna have the inverter here again generating high voltage, and I can show you that. So let me power it on. I'm powering this from my bench supply, and hold on, the meter is not in view, and you could see, so I'll use the ground here, and the output of the first one, you'll see we have close to 400 volts. So let me turn that off. Now in the case with the second bulb, it gets a bit interesting because now we have ground connected through here, through one of the lights. But if we move the switch to now powering both of the lights, then this gets disconnected, so we no longer have a connection to the ground on the CFLs, but instead ground is now connected to the same output as before. Hold on, that's not on beep. So ground is connected to here, but also to here, and this is the second wire that enables the second circuit that goes to the other end of the CFLs. And now when we have the two CFLs running, then power is applied through one, then it connects through both of the CFLs, and it connects on the other side. So basically when they're both working, we don't really have a ground. Now I won't be using any of that circuit because I will be replacing the whole thing with LEDs, and I plan to add a step up so I could have 12 volts because I'm gonna be using standard 12 volt LED strip. So the plan is that I'm gonna desolder these two wires, being the triggers, and this is the output. So the triggers, I'm gonna have power coming in directly to the step up converter, then ground will be switched exactly the same on both from the output, and we'll see if that works. Okay, so I have the first part ready, and I decided to change tactics a bit. So instead, at the beginning, my plan was that I'm gonna provide 6 volts from a battery and then step it up to 12. When I tried that with the step-up converter, that wasted a lot of energy in the step-up. So instead, I switched and I rewired this to come directly from 12 volts. So I'm gonna be using 3S configuration of a lithium battery, so around 12-ish volts, and I have it powered from the bench supply. And if I turn on the first one, now the first one lights, and if I turn the second one lights as well, but the rest of the circuit is not powered on because I only have 12 volts coming in to here. Now from here I'm gonna add a step down converter so I can be able to power the radio, and also the lights will also work on 12 volts because, as we saw before, they could also work up to 24 volts. And I now have the circuit complete, and I'm using the step down converter that I've shown in one of the previous videos that you can find up here. So I compared a bunch of those, and the way that this works now is that I'm powering this from 12 volt directly coming from my bench power supply, as well as 12 volts going to the lights in the front, and ground is separated and it's only connected to the step-up converter, to the step-down converter through the switch for the radio, and that powers the 6-volt circuit. So when I turn on the radio, you can hear that music starts to come out, and I don't want to get demonetized, so I'll turn it off. But now let's put everything back together in the case and figure out a placement for the step down. For the battery, I'm gonna be using 3 pairs of 18650s, so that should give us plenty of charge to power on the device, and combined they'll be at a nominal voltage of 11.1 volts. When fully charged, they will be up to 12.6, but that should be fine. Let's just tape them together. These are all salvaged batteries from laptops, and they would be perfect for the purpose because the device doesn't really require that much current and they can easily handle that. So let's connect them in series. Okay, here's the pack now wired up in series, and we get 11.6 volts. They're not really charged, but it is important in situation like this when we do power packs that we add a battery management system, or a BMS for short. This will ensure that all of the cells are charged to the same voltage and that they are not discharged below their threshold voltage. So let's solder this. The way that you wire this, you have a charge port and a discharge port. So this is where you input the voltage from the outside, and you have a point for all of the battery cells. So you have 0 volt that goes to the negative on the first cell, then you have 4.2 that goes to the positive, but also negative because those two are wired together, of the second. Then we have 8.4 volts, which is the positive and negative from the second and third pair. And then we have 12.6, which is the main positive of the entire pack. Here's the finished pack. I isolated all the contacts, and now we have two pads, so one for charging and one for discharging. I'm gonna now remove this lead acid battery, and instead we're gonna add the lithium one. And the lithium pack is a bit smaller than what the lead acid battery was, so I'm gonna add some cardboard to the gap. Ideally this would be filled with more lithium cells, but for now I'm gonna use just cardboard, and it's also smaller in terms of height, so I'm gonna add this piece here before adding the copper. But before that I need to solder the connections, so let's do that. Okay, so I do have here all of the inputs, and I'm gonna try and thread it from the underside. So I have the input for the buck converter, the input for the ambient LEDs, and also the input for the top LEDs coming in all here. And this would be the source of 12 volts, so I think that's okay. Let's solder it. Let's try that a bit better, or we can just add it from the top. Okay, so that's the positive, and this is the negative. To charge the battery, I'm gonna use a DC power jack. So now I'm just gonna solder some wires to the charge terminals on the battery, and then we'll see where we can place that connector. As one of the last steps for the assembly, I enlarged the hole for the antenna so I can pass through this new antenna, and I'm gonna use the existing screw to keep it together. So let's, okay, I can remove that for now. Add the screw, and we should be able to put this together now. And with that, here is now the lantern rebuilt. We can turn on the radio for a brief moment. And it works. That's okay. I don't want to get demonetized for copyright, so that can be stored away. We can turn on one of the lights or two of the lights. The alarm also works, so only briefly. We have the front spotlight, and the only thing that I wasn't able to make it work because I had to rewire those to work on 12 volts is the flasher that no longer flash, but I think we can live with that, and it's still a yellow light that should be interesting in case we need it as a warning, and everything else can be compared and combined as well. So that's that. If you think that you'll be interested in watching me create a flasher circuit for the warning light, then let me know in the comments. The only thing left is that I'll need to find a cover, and maybe I'll 3D print something when I get a 3D printer, and also a suitable charger, but for now I can use my bench power supply for that. And we can now use this on our camping trips. This was definitely a challenging video because it took way longer than I expected, and I had to solve quite a bunch of issues on how to wire and how to rewire everything, and it was definitely an interesting project for me. I hope it was the same for you. Don't forget to like and subscribe, and I'll see you all in the next one. Cheers!